Now, another very critical thing when we hear are called critical bands. When we talked about the basilar membrane, I said it was long and skinny, and it figures out what waves are coming in, and the part of the basilar membrane goes into action depending on whether you have a high-pitched sound coming up, a medium-pitched sound, or a low-pitched sound coming in, right? Very true, except for one thing. It is a long, straight wire. So when two sounds come in that are close enough in frequency to each other, the basilar membrane doesn't know what part actually to go into action. The amount by which you cannot tell the two frequencies apart are called critical bands. So I will show you another picture like this. So if two frequencies that are coming in are far away from each other, you can tell these frequencies. But as those frequencies become smaller and smaller, this shadow region becomes bigger and bigger, to the point where these two frequencies coming in, your brain doesn't know which one. And that's also the phenomenon that people use for masking. Think about it this way. A basilar membrane is a long, thin wire. High frequency sounds, low frequency sounds. But what's the difference between this frequency and say that frequency? They're close enough to each other where the membrane doesn't know what part do I do that? Like what part goes into action what part becomes the standing wave for me? And now I'm going to show you this picture again. Do you see this picture? That's in response to a sound coming in. And this picture could also be here or in the middle. Like some part of this basilar membrane will go into action. And this actually has tiny, tiny threads which are connected with neurons, which are connected with your brain, which tells the brain, okay, this sound came in, and this sound came in, and this sound came in. And it has to happen in like milliseconds, microseconds, because there is not a time delay between the sound and your brain. There cannot be. And it's way more complicated than what I'm making it seem like, right? There's millions of these hairs and there's millions of neurons and they're all connected together. And the older we get, so here's the thing, you know, like how old people get deaf over time? What starts to happen is the same thing that happens with our eyes, right? The muscles in our eyes, even if you have 20/20 vision when you start off, when you turn about 40, 45, what happens? You start needing those glasses, right? The readers that you all, I now need glasses. I can't see anything anymore, but like you need all those readers. What is actually happening? Your muscles in your eyes are getting weakened. So the tightness of those muscles, they get weaker as the time goes by. So they don't focus as quickly as they used to. The same thing happens in our ears. Remember, this is a tight, taut muscle that's held like this. But what happens over time? It will get a little saggy and a little more saggy and a little more saggy as the time goes by. So the basilar membrane is not as reactive to sounds as it was before. And that's old age. Everything just kind of becomes more droopy as the time goes by, right? And that's what's happening. That's why old people will always be like, what? What did you say? Say it louder. What? I'm getting to that age. Does that make sense? Yeah? Bobbleheads? Good. Okay. So that is the critical band concept. It was introduced in the 1960s by, how do I say this word? George von Bixby. And all because the basilar membrane is a straight wire or thread, right? So it goes up and down when high frequency sound comes in, it goes up and down when low frequency sound comes in, But if two frequencies are very close to each other that come in, it doesn't know. So this is the only thing that's vibrating. So it says, okay, approximately this much frequency came in. And those gaps are called critical bands, in which we cannot tell the difference between one frequency and the next. So that is called critical band. But the most fascinating thing is the actual width of a critical band. It's about 1 millimeter. Do you know how big 1 millimeter is? About EA big. So the length of a critical band is 1 millimeter. So if this is a centimeter, there's 10 in there. It's very tiny. People can mask one frequency with another frequency if they fall within the critical band of your basilar membrane. So these are the definitions I want you to write. These are two good definitions of what a critical band is. Definition 1 is that when two pure tones are so close in frequency that there is a considerable overlap in their amplitude on the basilar membrane, they are said to lie within one critical band. Same definition, except slightly off. Critical band is the specific area on the basilar membrane that goes into vibration in resonance with an incoming tone. So there are about 24 critical bands along our basilar membrane, and each of them is about 1.3 millimeters long. About EA big. Very, very tiny.